Hello all, welcome to JSM Learn. Here in this session we are going to discuss previous IIT JEE questions from the chapter Motion in a Plane of the topic Projectile Motion. Here comes the first question. The two projectiles are projected with the same initial velocities at 15 degrees and 30 degrees with the horizontal. The ratio of their range is 1:x. The value of x he is asking. So this is a very easy question to solve. We just need to know the formula of range. So r is equals to u square sine 2 theta by g. So where g is acceleration due to gravity. From this formula we have two different angles but same initial speeds. So if you write for this, r1 will be equal to u square sine 2 theta 1 by g. So this will be the first range, and if you take for the next, r2 is equals to u square sine 2 theta 2 by g. This will be the second range. He is given that the ratio of their ranges, these are the two ranges. One is projected at theta 1 which is equals to 15 degrees and another one is projected with theta 2 which is 30 degrees. So like this, two projectiles there, one is 15 degrees, one is 30 degrees. Somewhat two different ranges they covered. Their ratio he is asking. So if you consider r1 by r2, the ratio is equals to, in both, so u square sine 2 into theta 1 value is 15 degrees by g. In the denominator r2 there, so I am writing as a reciprocal. So g by u square sine 2 into theta 2 value is 30 degrees. So here u square get cancelled because their initial speeds are same, and now g get cancelled. What left? So r1 by r2 is equals to, we have given with 1 by x, that is 1:x. So 1 by x is equals to sine 30 degrees by sine 60 degrees. So if you want to solve this, 1 by x is equals to, sine 30 value is 1 by 2. And in the denominator sine 60 there, sine 60 is nothing but root 3 by 2. So denominator root 3 by 2, it will be reciprocated. So these two get cancelled. So 1 by x is equals to 1 by root 3. So x value will be equal to root 3. So from the options, option B is correct for this question. And next, if you go to the next question, an object is projected with a kinetic energy k from a point A. So this is a projectile path which is given as a diagram. So at this point it is projected at 60 degrees angle. At this point it has a kinetic energy k. So with the kinetic energy k from a point A at an angle 60 degrees. Now this is the highest point. If we see in this, the maximum height point h given, and here only it is having horizontal velocity. He given with the direction. At the highest point only horizontal velocity will be there for the projectile. Then so this velocity we can take here u cos theta, and this will be u sin theta. So whenever a projectile is projected, as it is reaching the maximum height, its vertical velocity becomes 0. After reaching maximum height, after reaching maximum height, this value becomes 0, and when it is coming down, again it increases in the negative direction. Initially it is decreasing because of acceleration due to gravity acting in the downward direction, and after reaching this point it will increase in the negative direction. We have 3 points here, A, B, C. Now he is asking for the ratio of the difference in kinetic energies at points B and C to that of at point A. So in the figure we have provided like that. So initial angle of projection is 60 degrees and initial kinetic energy is k. So if you look at the point B, so kinetic energy at B I am writing as kb, which can be only horizontal velocity there. So we can write half m u cos theta whole square, because only horizontal velocity will be there. So this can be written as 1 by 2 into m into u square cos theta whole square means cos square theta, but here angle 60 is given. So if you write that cos square 60 degrees, so this can be 1 by 2 into mu square. Cos square 60 means cos 60 is 1 by 2, 1 by 2 whole square, it will become 1 by 4. But we got here 1 by 2 times 1 by 4 times of half mu square. If you look at the initial point, here u cos theta horizontal component, u sin theta vertical component, which are produced from the initial velocity vector. So at this point the kinetic energy k, we can write it as half mu square, because that is the only velocity it has at that point. Now this half mu square, from this equation we can write half mu square, we can write as k. So we can keep kb is equals to 1 by 4 times of initial kinetic energy. Let us keep it as equation number 2. Now if you go to the point C, at this point the kinetic energy of the particle will be same as the point of projection, because initially it is projecting with the upward velocity. Now when it is landing, again downward velocity, which is equal but opposite in magnitude. The horizontal velocity will be in the same direction this way, but the vertical velocity here we projected with u sin theta, here it will be minus u sin theta. So the magnitude will be same, initial and final velocities. So at C I am writing kc will be equal to half mu square. So this will be equation number 3, which can also written as kc is equals to k. So the question is the ratio of the difference in kinetic energies at points B and C. So difference in kinetic energies at point B and C means here it will be high or here it will be high. Obviously at the point C, at the point A, the kinetic energy will be high. So we can take Kc minus Kb by Ka is equals to Kc value is K minus Kb, the kinetic energy at B. What we got? 1 by 4 times of K. So we can write K by 4 minus divided by K. Ka will be K. So which will be equal to 3K by 4 in the denominator K there. So K get cancelled. What we get? 3 by 4 as the answer. The ratio of difference in kinetic energies at points B and C to the point at A will be 3 by 4 or 3:4. So option C suits well. The next question, a projectile is thrown upward at an angle 60 with the horizontal. The speed of the projectile is 20 meter per second when the direction of motion is 45 degrees. So initially it is projected at 60 degrees angle. Yes. So we can take the projectile motion like this. So 60 degrees angle of projection is there. Now with the horizontal, the speed of the projectile is 20 meter per second when its direction of motion is 45 degrees. It is projected. After projecting, it reached 45 degrees angle with the horizontal. Like this it is projected. After reaching with 45 degrees, he given velocity. So that will be some final velocity after some time. We don't know that time. Now with the horizontal, the initial speed of the projectile, he is asking for initial speed. At this point, whenever it is projected, at that point the initial velocity is asking. So we have theta value, we have alpha value. So from this velocity, so at this point let us consider here, this will be V, here final velocity there, it is making theta 45 here, alpha value. So this will be theta value. So from this we need to find u value. So for that I am using V is equals to 20 meter per second. So from this we can write Vx, x component of velocity. What it will be, sir? U cos theta, here theta value 45. Vx is equals to 20 into cos 45 and Vy is equals to 20 into sin 45. So this can be sin 45 value 1 by root 2. So it can be 10 root 2 meter per second in vertical direction, and here also 10 root 2 meter per second in horizontal direction. But we know what the horizontal velocity of the projectile remains constant throughout the projectile motion. So here u cos theta we projected upward, u sin theta upward velocity, u cos theta horizontal velocity. So this u cos theta value here horizontal velocity after some time also it will be same. So from that equation we can write Vx is equals to ux is equals to constant it should be. So if it has to be constant means the Vx value should satisfy the value of ux. So Vx we got 10 root 2 is equals to ux means u cos theta. Here theta is the angle of projection. We should not take 45 degrees as theta. It is alpha. After some time it is another angle. Now 10 root 2 is equals to u into cos 60 degrees. Here cos 60 degrees is equals to 1 by 2. So 10 root 2 is equals to u by 2. So u is equals to 20 root 2 meter per second. So he is asking for the value of initial velocity. Here comes the initial velocity from options. Option B is correct. Now if you go to the next question, a boy throws a ball into air at 45 degrees from the horizontal. So there is a boy projecting at 45 degrees. A ball he is projecting. But why he is projecting, sir? To land it on a roof of a building. There is a building, you see there is a building. So he is throwing at 45 degrees to land it on the building. So the building height is h, we don't know. Let us consider there is a building h, there is a building with a height h. Okay, so it lands on the building. Understood? Now at this point the maximum height of the projectile come, and his purpose is to throw upon to the building. It is fallen on the building. At what time? If the ball attains maximum height in 2 seconds. So to reach this maximum height, he took time of ascent. The time taken to reach the maximum height is time of ascent, that 2 seconds he took, and lands on the building in 3 seconds. So if time of ascent is 2 seconds, what is time of flight? Time of flight will be 2 times of time of ascent. So this can be 2 into 2 seconds, that is 4 seconds. So total time of flight is 4 seconds. Now initial angle of projection is 45 degrees, g value given 10 meter per second square. He is asking for the height, not maximum height of the projectile. He is not asking maximum height of the projectile. He is asking the height of the building where he wants to land the projectile, this height. So that h value to find that. So time of flight formula t is equals to 2u sin theta by g. So from this 2 into u value we don't know. So sin 45 by g value 10 into u value I am writing separately. Here t value is 4. So take all the values to one side. So 40 by 2 by root 2 is equals to u. So 2 ones are 2 twos are. So initial velocity of projection will be 20 root 2 meter per second. So with this velocity he projected upon to the building. It landed on the building at what time? It landed on the building after 3 seconds. So from this we have to find initial velocity is this much. So ux will be equal to u cos 45 and uy is equals to u sin 45. Why I am taking these values? Because we need vertical height. It is thrown horizontally, it is thrown vertically at a time. So when it is landing on the building, it covers a vertical distance and as well as horizontal distance. But in this question he is not asked about horizontal distance, he is asked about vertical distance. So for that we need vertical velocity. So here if you solve ux is equals to u 20 root 2 by 1 by root 2. So this will be cancelled. It will be 20 meter per second. And even if you solve here also, you will get uy is equals to 20 meter per second. So with 20 meter per second, it is going upward from initial point. Now the height, the vertical distance it travelled can be obtained from the equations of motion. What is we have? So sy, vertical distance, here we am taking as height of the building. It is not maximum height, it is height of the building from where he to where he lands. So h is equals to ut, u in vertical direction, ut minus half gt square. So if you substitute for that, h is equals to uy value we have 20. After how much time it is landed on the building? 3 seconds. After how much time? 3 seconds after it is landing on the building. So up to here 2 seconds, and if you continue, if the building is not there, this path will continue until here. It will take 4 seconds, but in this, during this path only the building is there. So at that point it is hitting. So 3 seconds, 20 into 3 minus 1 by 2 into g value 10. So 3 square. So 2 ones are 2 5s are. So 23s are 60 minus 5. 3 square is 9. So we can write 5 9s are 45. So 60 minus 45 is 15 meters. So height of the building h is equals to 15 meters. So from options, option C is correct. So this is the way to solve the questions based on projectile motion, and this question may be considered for the inclined plane. So from here to here. Thank you for watching. Subscribe to JSM Learn.